So here we'll be walking through the process of DNA replication using this model. There are multiple pieces that go into the process of DNA replication, and we have some of them, not all of them. We have two of the enzymes. Today we are going to be looking at specifically helicase, and we have two DNA polymerases here. We have our parental DNA, or the DNA that we are going to start with, and we have a bunch of gray nucleotides that are going to be our new nucleotides that we're adding onto our molecule as we are replicating. If you look closely at each nucleotide, you can see that there's an arrow on one side and no arrow on the other side. The arrow side is our 3' end, and the no arrow side, so the other side, is our 5' end. That's important to pay attention to as we move through DNA replication, because this process can only happen in a 5' to 3' direction. So the DNA will only be added onto a specific end of our new DNA molecule. The first step that happens in DNA replication is that the enzyme helicase is going to break the hydrogen bonds that are found between our nucleotides, between our DNA strands, and it is going to create two single strands that we can add onto. I'm going to start by just separating 11 of them. That way we can just start to model this process. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we can get 11 of those out there. Okay. So now that we have 11 of those out, I'm going to start making the leading strand. So in order to make DNA, we need DNA polymerase. This is our enzyme that adds on our nucleotides. I'm going to find the strand of DNA that has the 3' end. So here we don't see an arrow at the end, so it's not 3', but here we do see an arrow. It is 3', right? So I'm going to add the DNA polymerase. I'm going to match the pictures up. So our DNA is going to go into polymerase like this. And as it is working, or as it is moving, we are going to start by adding the matching base pairs, right? While I'm adding these base pairs, I'm making sure that I'm following the complementary base pair rules. I am doing C to G, A to T, and everything like that. And this is going to keep going until it can no longer move. Okay. So now that the leading strand is done, I'm going to replicate our lagging strand. Remember that the lagging strand is going to move opposite. In reality, both of these strands would be replicated at the exact same time, but to simplify, I'm just doing one strand at a time. So our lagging strand is going to be moving away from the helicase. So I'm going to take our DNA polymerase, and we are going to start it as close to the helicase, just right next to it. This way, though. You can notice, it's in the right direction if both of these black arrows are pointing opposite directions. Just like with the leading strand, I'm going to make sure that I am adding the base pairs based on the base pair rules. So A to T, C to G, things like that. We're just going to keep moving it. Notice how this is moving away from our helicase. And then lastly, we have a C and a G. So now I'm going to continue the rest of replication until the DNA molecule is fully replicated. So what's going to happen is our DNA is going to move through the helicase again, right? And because up here we have our leading strand, DNA polymerase will be able to just continue straight down right up until it hits the helicase. However, at the bottom here, with our lagging strand, our DNA polymerase is going to have to come off of our new DNA strand and jump all the way back here and restart. So we are going to restart at this T here. So that is going to need an A. Where did my bag go? Here it is. So we put an A. This next T needs another A. G needs a C. Nope, that is a C. C needs a G. And this DNA polymerase is going to continue this way. Now that we have our DNA fully replicated, I have two daughter strands, two daughter molecules, both identical to our parental strands, right? And I can see how this is semi-conservative. Remember, the DNA that we started with had all of the nucleotides that are colored, and the nucleotides that we added were the gray ones. Now I have two molecules, each that have one half of the colored nucleotides and one half of the gray nucleotides. This shows that the process of DNA replication is semi-conservative because half of the old DNA or the parental DNA, so the colored nucleotides, strand was saved inside our new DNA molecules.